Okay, this is a sailing blind parametric equation that's on the front of your homework. Mr. Said and Mrs. Villers were out in their sailboats on Canyon Lake enjoying the one last bit of summer fun with their families before school started. Suddenly, a mysterious fog enveloped them, and they were unable to see where they were going. Recklessly, they refused to drop anchor. Both captains turned on their transponders so that the authorities were able to monitor the boat's positions from shore. This is a very exciting problem, isn't it? When the transponders were turned on, Mrs. Villers was located 900 meters east of the nearest navigational buoy. Mr. Said was 100 meters north of the same buoy. So let's get that started real quick. We're going to put Villers in red. And so you can go ahead. So I'm going to just make a ledger here. Villers is going to be in red. And where am I? 900 meters east. Do you remember northeast, southwest? What did y'all learn? I learned never eat soggy watermelon, slimy worms, waffles. Okay. So either way, yes. Either way, I'm 900 east of the buoy, and right here is the buoy. So 900 east of the buoy. Let's go with Mr. Said. What are we putting him in blue? Chelsea requested for blue. I mean, Celeste was in blue. Where is he? 100 north. 100 north. Okay, that's all we know at the moment. The next part says, after 1 minute of tracking the sailboats, Mrs. Villers moved 3 meters west and 2 meters north. Now, on my graph I have going here, 2 meters and 3 meters is going to be too hard to draw. So in my hundreds world that I put here in my scale of 100, what's the same as 3 meters west and 2 meters north could be what? 300 meters west and 200 meters north. That would be after 100 minutes. Is this time in minutes, did it say? Okay, so the time is in minutes. So the same, after 1 minute, it would 2 meters north and 3 meters west, but it's hard to graph that. So we'll just find out what it was 100 minutes later. So let's go back to red. And so we're going to go 2 north and 3 west. Is that what it said? Let's do that a few times. 2 north, 3 west. And if you have a ruler at this point, it would be good. I don't, so I'm going to okay. So now I'm traveling this yes, but it should be okay. 1, 2, 3. Oh, let's see. 1, 2, 1, 2. I'm okay because I was even, right? My scale was by 50s. I did count it off, but so we should still be 200, 100, 200, 300. We're still okay. So up 200. Yeah, look at if we're on the second paragraph, you can see that it says 3 meters west and 2 meters north. Okay, so let's go with Mr. Said. Mr. Said, check that one out. What does it say? 4 east and 1 north. 4 east and 1 north. So 400, I'll count correctly by hundreds this time. 100, 200, 300, 400, and 100 north. So I'm going to be here, 100. So go again. Yeah, and okay, and Said is, of course, is moving this direction. Okay, well, it says, well, you can do 50s or 100. It's still, you know, if you just count by lines, it's up one line over 4. Or you can go up 2 lines, which would be 100, since my scale is by 50s. So as long as you're consistent, you're good. Consistency is good here. Okay. So now we've got these drawn. Let's see where we were in our story. So Mr. Said, 4 meters east and 1 meter north. Fortunately, they slowed down in the thick, dense fog. The ships continued in the same movement as they progressed across the fog-covered lake. Are Mr. Said and Mrs. Villars headed toward unimaginable disaster, or will they narrowly escape to sail another day? Very exciting. So we have this. So if I didn't know anything about the timing, it would look like their paths at least cross each other, correct? We just don't know anything about their timing. Okay, so let's look. Part B. Since the sailboats traveled in straight lines, write the equation for the path of each sailboat. Now, we're just using good old linear. This is not, they just want the path. They don't want the timing part of it, okay? So, let's go with Villars first. What would this be? I'm going to go ahead. This is part B. And so, Villars would be y equals, how do we do this? What is the slope here? It was up how many? Up, I think it was up 2 over 3 in the positive or negative. So it's negative 2/3 x, and then we need our y-intercept. And luckily I drew it far enough to see that the y-intercept here is 600. Okay, let's go with Said. Y equals, okay, his y-intercept is easy. It's plus 100, and the slope was up 1 over 4 x plus 100. Okay, easy enough. That's part B. Let's move on to part C. Did the 2 sailboats pass through the same location? Yes or no? Yes, they did. And it says, if so, what is the location? Does it say that here? Did I make that up? Yes, same location. If so, what is the location? Do we have that? How are we going to figure that out? You want to intersect it on the calculator? I think that's a grand idea. Oh, we don't have any, so y'all can look at mine. If you have it, great. Okay, so help me remember. Negative 2/3 x plus, was it 900? 600. Oh, that's right, 600. And Mr. Said was 1/4 plus 100. Okay, I'm gonna reset my window to match what I had here, which is, I'll leave -5, but I need to go to 1,000, correct? And let's do the same thing. Let's put -5, just have a little bit of border, and go to 1,000. Okay, so let's graph this. There's Mrs. Villars. There's Mr. Said. And we're going to intersect. Choice 5. And we have it 545.454, or 455 if we round correctly, and 236.364. Let's go back and record that. How are we going to record that? Let's put part C. We'll say, did the 2 sailboats pass through the same location? Yes. And so let's get the ordered pair first, which was, you know what? Let's just do it like this. 545 point, what was it? 455. And that's east of the buoy. We'll put, and 236.36 what? 364, and that's north of the buoy, right? Okay. So that was pretty easy with our calculator to find out where they actually, the paths actually cross. Okay, let's go into part D. Part D says, if two objects pass through the same point, do they necessarily collide? And your answer is no, not necessarily. Why not? Timing may be off. Uh-huh. Okay. E. Now it's wanting us to write it in parametrics. Okay. So we're moving into our parametric equations now. Here's what I think I would do. Does it show this on your, yes, it shows this. So you want to put x of Saeed over time and the y of Saeed over time. And you learned this in the first video with the car crash from the Khan Academy, is that we separate everything that goes horizontally from everything that's vertically, and then put the time variable in there. So we're also going to have an x for Villers based on time and a y for Villers based on time. Okay, so let's start with Saeed. Saeed started, where does it start? Did he start horizontally, left or right, or x? Did he start left or right of the buoy? Going back to look at the picture. No, he didn't. So that's not left or right. But how fast did it move left or right? Didn't he move 4? It wasn't 400. Every time it was just 4, wasn't it? Go back and look. 4 meters east. Okay. So we have to base it on 1 minute because t is per minute. And the directions were 4 every minute. Okay. So then let's put, yeah, I can't put 400 there, can I? Because that would make me moving 400 meters every second. Yes, but it defines my time as seconds. It defines my time as seconds. So let's, or minutes, didn't it? It defines my time as minutes. So I've got to stick with that. Okay. The next thing is y. How high up was vertically? Was Saeed vertically above the buoy? 100, right? And then how fast did it move? Did it move up or down, north or south? He was north, what? 1 meter. So it's plus 1 meter every time, plus 1t. Does this make sense? Okay. 1t because it says he's going north, 1 meter north every minute. If you look back at the original, 1 meter north every minute. Okay, let's go to Villers. Villers in the x direction. Did I start left or right of the buoy? To the right, it was east. How many meters? 900. Now, what did I move in the x direction? 3 meters west, and west is coming back to the left, so that would be a negative movement. And wasn't it 3? 3 every time. And then in the y direction, did I start up or down from the buoy? Nope. I started even vertically with the buoy, but moved 2 meters north. So we're going to have 2t. So those are your parametric equations for this scenario. Those are your parametric equations for this scenario. Okay. Now F says, use the parametric equations to determine when the boats are at the same horizontal position. When the boats are at the same horizontal position. So here's how you solve these parametrically to see if they collide. Doesn't it, all 3 variables are going to have to align. In other words, I'm going to have to be at the same place horizontally and vertically at the same time. Does this make sense? I'm at the same place horizontally and vertically, which would mean my ordered pair was the same, but it's all got to happen at the same time. Okay, so what we're going to do is let's go, it says, part E says, I'm sorry, is it E? No, it's F. Part F says, when are the boats at the same position horizontally? Well, how am I going to do that? Anybody? When are they the same place horizontally? What's horizontal, X's or Y's? X's, right? Our X's. So that means 4t. When does the 4t equal the 900 minus 3t? We got it? When does 4t equal 900 minus 3t? Well, that's 7t equals 900. So t equals 900 sevenths, which is 128.571. I think y'all told me this time is in minutes. So 128 minutes later, we are horizontally aligned. The question is, are we vertically aligned? Horizontally aligned just means we're same on the X, but we need to see if the Y's are the same at the same time. So how can we figure this out? Plug the T's in for Y. Let's see what it says next. Part G says, use the value from F to determine whether the boats collide. So here's what we're going to do. We're going to take our Y values, which is, what was Saeed's Y value? 100. Okay, so equals 100 plus 128.571, which obviously would be 228. Okay, what about the Y for Villers? Well, Y for Villers was just 2 times T, so it's 2 times 128.571, which equals 257. 257.143. So, again, the question was, use the value from F to determine whether the boats collide. What do you think? No, they do not collide. Thank goodness. I'll be here tomorrow since I did not die in this reckless abandonment that I...
So logic proved correct. You didn't die. Therefore, you can be here to teach.
That's right. Okay, and you have to justify your answer. And so you can say something like, they are not at the same distance vertically at the same time they're at the same place horizontally. They're not at the same vertical and horizontal location at the same time. Okay, I didn't write all that down, but again, I said they're not at the same vertical and horizontal distance at the same time. Okay, let's look at this question on the calculator. You may not even know that your calculator has a parametric mode. So to put your calculator in parametric mode, push mode. If you notice down here, we've got function mode, parametric mode, and so you want par, which means parametric mode. And the kind of cool thing is, now push y equals, and look what it does. It gives you an x over time and a y over time. So it knows that you need to separate, just like we learned that parametric separates the horizontal movement based on time from the vertical movement based on time. So the equations we had, let's put Mr. Saeed in first, which was 4. And look at this. When you push your x, notice after the x there's a t. As soon as you push it, for parametrics, it knows you need time and not x, so it knows to put a t there. Okay, for the y equation, we had 100 plus 1 every time. So that's Mr. Saeed's movement, and then the Ms. Villers was 900. For the x, we had 900 minus 3t And then for the y, we had 2t. Okay, so let's look at the window. And the window is going to be kind of interesting. Look at the window. It gives you a t minimum. That means you want your time to start where? So we're going to start at time 0. And then t max, it has right now 6 point something. I think I need my time to go more than 6 seconds, because in the problem we had that time was 128. So if we only go six ticks out, we'll miss it. So let's do 200. Okay, now this t-step is about how fast you want it to graph. So if you push graph and it's going really slow, you go back and change this t-step to a bigger number. I don't know exactly what 0.1 is going to do, so I'm just going to leave it there right now. Okay, so my x minimum, remember we went from 0 to 1,000 in both the x and the y direction. So this window is actually good. From -5 to 1,000 and -1 to 1,000 looks great. Okay, so one other thing I want to do before we go is, it's kind of fun to go back and push enter over here on the left until you get a circle with a tail, circle with a line behind it. That way you can, it kind of symbolizes the boat. It looks like the boat traveling and leaving its path. Okay, here we go. Let's push graph. And what I can tell right now already is they're moving way too slow. I do not want to wait on this. Way too slow. So I'm going to push second on, which turns it off. Go back to y equals. Actually, I think I need to go back to to window. Let's go to window. Window. I promise I want to go to window. There we go. So let's make this go a lot faster. Like, let's go to 1. That might be too fast, but let's see. Okay, graph. Nope, it's definitely not too fast. Let's wait just a second and see what happens. So this is the one boat traveling along, and the other boat hasn't even come onto the scene yet. Either that or I haven't graphed it correctly. And I think we have an issue because I don't see the second one at all. Let's see what the issue is. Let's stop it. Let's go back to y equals and see why that is. Oh, is it coming? I was just not patient enough. Okay, let's make it go a little bit faster. Let's put 1.5. Okay, and graph. It's still a little slow. Sometimes you need it to go slow because sometimes they come close to crashing, but they don't. And so it's better to go slow. Where's the second guy? Should be coming. Here it goes. No. Oh, there it is. So these clearly did not collide. Clearly did not collide because one boat is well past the other one. And that's what we got when we did it by hand. So that's parametric mode on your calculator, and it's kind of fun to watch what happens on that.